All right, guys, let's jump back into it. So, they are asking us, is it consistent or is it inconsistent? And is it independent or dependent? You can see that there are two categories of consistent. One inconsistent. Once anything is inconsistent, it's inconsistent. Doesn't matter. It's inconsistent. Second option, when it's dependent, it can be one of two different things. It could be independent or dependent. Independent meaning they do not rely upon each other. Dependent meaning they do. They're dependent upon each other. Now, let's look at what they're asking us. In example A, y equals negative x plus 2 and y equals x plus 1. Again, a few refreshers here real quick. We're looking at lines, coordinate grids, ordered pairs, graphed equations in y equals mx plus b form. Luckily, again, in this first lesson, they have graphed them for us. We're set up. Let's just look at them and understand how to identify what they are. Okay, y equals, let's go ahead and identify each one. Ignore the colors. These colors have nothing to do with what I've done up here. But let's look at A right here. We're going to go ahead and look at this. Y equals negative x plus 2. Let's refresh ourselves. And y equals mx plus b format. What is m? Y equals mx plus b. M is the slope. That's right, rise over run. B. B is the y-intercept, where it hits the y line. Remember, ordered pairs are always x, y. Where does it hit the y line? Origin is in the middle, positive y up here, negative y down here. Where does it hit the y? Right now, we know this one hits y equals negative x plus 2. Negative slope plus y is where it hits. This equation right here, which is this line. Now, let's compare that to y equals x plus 1. Right away, I'm seeing a positive slope. The slope is going to be positive. x1, it's going through the y-intercept at a positive 1 unit above the origin. Luckily, they've identified this one for us. Looking at these two lines, it is asking us, determine whether it is consistent or inconsistent. First of all, first question, consistent or inconsistent? Correct. Consistent. They touch. There is a point. There's an ordered pair where they connect. That didn't work out too well. Also, is it independent or dependent? Is there one point where it's an independent point, or are there multiple dependent points that go on forever? Correct. This is consistent and independent. So your answer, looking at this, would be graphing it, looking at it, writing the words. This is consistent and this is also independent. That is example A. Let's move down. Oh, can't move down that far. Example B. Y equals negative x plus 2. Here it is right here. Ooh, that red's off. Comparing with 3x plus 3y equals a negative 3. You're probably wondering why is it written so weird. It is not written in y equals mx plus b format. That does need to be solved. At the moment, let's not worry about it. They're letting us know. It is this line right here. Looking at those two lines, what are they? Correct, they're parallel. Once we know they're parallel, question is asking us, consistent or inconsistent? Right away, inconsistent. Nothing else matters, those are inconsistent. Let's move on. Looking down here, example C. 3x plus 3y equals negative 3. Again, not in y equals mx plus b format. However, they've graphed it for us. Comparing that with y equals negative x minus 1. They've graphed that for us as well. First thing, what do we notice? Obviously, it's the same line. Makes it easy. We know the same line is consistent and dependent.